These are the basic inequalities, just like an equation. All right, we're going to get x by itself, except we got to solve and graph our inequalities. Okay, so we'll be graphing just number line graphs for these. So we'll add our 5, take it to the other side. Again, you guys know how to do this stuff. Divide by 3. We get x is less than or equal to 4. So then we also draw our graph for that solution. So what I usually do is put whatever number we got in the middle and go 1 to the left, 1 to the right. So now we just got to think about some things. When it's just less than or just greater than, you have an open circle, right? When it's got the equal to, like this one, we have to fill it in. That means we're including the number 4. And then it says less than, so 3, 2, 1, 0, and the negatives are less than 4. So the graph is a picture of all the answers. We couldn't list all the answers because there's an infinite number of answers to inequalities. So that's why we draw a picture, a graph. So that's all a graph is, remember, a picture of all the solutions. All right? Pretty easy, right? Simple, you can do it, no problem. And then we got another one here. Just go through it again. We'll subtract 8 to get it to the other side. Greater than or equal to, we get 6, then we divide by -2. Now, on inequalities, remember, hopefully you remember this from years past, if you multiply or divide both sides by a negative, what happens to your inequality symbol? You got to flip it over, right? So that's a detail we got to remember. So this becomes less than or equal to -3. And then again, we'll graph it. So -3 is in the middle, -4 would be to the left, -2 to the right. Remember, that's the right order for those. Let's make sure we put them in the right order. Every year I get kids that switch that. Again, it's less than or equal to, so we got a solid dot at -3, less than will be towards the -4. So the basic, simple inequality. Okay? Any questions? All right. Another type we're going to look at today is called compound inequalities, where you got more than one. Okay? Same thing, you're just going to do 2. But then you're going to graph the 2 answers on the same number line when you have a compound one. So we're going to divide both sides by 4. We get x is less or equal to -2. And then we'll subtract the 1. And divide by -2. So we divide by -2. We got to flip it. Okay, so there's my 2 answers. So I'm supposed to graph that solution. Okay? So when it's an and problem, your solution has to work in both inequalities. So once you graph, basically what I do is I graph each one separately, and then I see where they overlap. That's the solution. That's the correct graph, where the 2 overlap. So we got 3 here, so 2 would be here, 4 would be here. Oh, I got a -2 also. I should add that in there. Let's do this. Move this over. Get rid of that. So, again, I'll just put all the numbers in, but you don't have to put all the numbers in if you don't want. Okay, so the first one here, -2, less than or equal to, so again, this including the -2 would go this way. If we make this one in green, +3, less than or equal to, okay? So we'll make red where they overlap. So where do they overlap? From -2 on, right? So the The correct graph for this that works in both sets it's an and is from -2 to the left. So basically the blue one, too, they're the same. So when it's an and, it's got to work for both. When it's an or, it only has to work for one or the other. Usually the ands go towards each other. This time they went the same direction, but usually they go towards each other, and that's just where they overlap from the one to the other. And the ors usually go opposite directions, but not all the time. Sometimes they go in the same direction, so then you got to think about it a little bit more. Any questions on that? Sometimes they do these compound inequalities, and they look like one problem, like this. Okay, but there's actually two problems there. Okay, there's this problem, and there's this problem. Okay, so a lot of kids will just write them separate. When it's less than, or just less than or equal to, they're ands problems. Okay, when it's greater than or equal to or greater than, they're or problems. Unless they already write it in there, like the one said and when it started. But usually, they won't put the words in there. So less than, so what you can think of as, think of it like this, add a D, so the word and's in there. And instead of spelling greater ER, spell it OR. So there's the OR, and there's the and. If you think of it like that, you can remember which one's which. So again, just subtract 5. So we get 7 is less or equal to X. This is a less than, so it's an and problem. And then the blue one, X plus 5, less or equal to 19. Again, just subtract 5. And X is less or equal to 14. Okay? So if you want, you could put these two together and write it like this. 7 is less than or equal to X, which is less than or equal to 14. Or you can leave them separate, but you still have to graph it. Okay? So 7's here, let's say 10's here, 14's down here. Okay? So at 7, we got a solid dot because of the equal to. And at the 14, the solid dot, it's got equal to. Less than 14's there. Now this is saying 7 is less than or equal to these numbers. So 7 is less than the numbers over here, right? So this actually goes this way. So where the two overlap, then, would we, just, that's what usually happens when it's an and problem. They go towards each other from one number to the other. Okay, some people will do this. 12, X plus 5, 19. You can do this if you want, if you don't confuse yourself. To get X alone, you got to subtract 5. Well, when it's in the middle, you got to do it to the right end and the left end. You get X in the middle, and then you got your 7 and your 14. So if you want to do it that way, you can, instead of writing both of them. But, that way is fine. Or like that. And then a graph. Any questions on compound inequality? Okay. One other type I want to show you, because these three are pretty easy, so I just lump those three together. When we have any absolute value signs around them. Okay, that's straight lines. Now remember, absolute value means how far from 0 you are on the number line. It's a distance. It's always a positive number. If I'm at 3 on positive 3 on the number line is 3 units from 0, right? If I'm at negative 3 on the number line, it's also 3 units from 0. Okay, so when you have absolute value inequality problems, there's actually 2 problems there. Okay? So here are the 2 problems. First one is whatever you see. 3x minus 2 less than or equal to 4. Nothing changes. Since it's less than, it's an and problem. Okay, the other one is still 3x minus 2. The part inside the absolute value symbols does not change. Okay? Do not change that. You hear me? Don't you do it, Alan. Okay? Don't change this part. They're both, in both problems, that's the same. Okay, every year I get somebody, Paul, that thinks they gotta change that to a plus. Don't you do it. Got rewards. What you do change is the inequality symbol, switch it, and make that negative 4. Okay? So you're thinking like you multiplied both sides by negative 1. So you gotta put the inequality symbol. Because remember, absolute value means how far from 0. So the absolute value of this is less than or equal to 4. It could be positive 4 or negative 4. That's both of those ends are 4 units from 0 on the number line, right? So that's why we have to do that. Then just want you, the procedure then to finish to solve for x is the same. Add 4 and divide by 3. It's okay to get fraction answers. Not wrong. And then the red one, add 2, and divide by 3. Again, oops, less than or equal to. And then we got 2. All right, so our number line, we're supposed to solve and graph. 0 would be here, 1, 2. I'm putting all of them in just so you can see. But again, you don't have to write them all in if you don't want. All right, so 2 is here, positive 2. Solid is less than, everything's got the equal to. I should have put an example that didn't have the equal to, so we'd have an open circle. And it goes that way, less than, right? Negative 2/3 is right here, right? Not quite, no it isn't. I went to the wrong spot, right here, right? Negative 2/3, not quite negative 1. And it says greater than or equal to, so that would go this way. Since it's an and, what am I looking for? Where they overlap, right? So, it's from there to there. All the numbers from there to there will work. Okay? Let's pick one. Let's pick the number 1. What's 3 times 1? 3 minus 2. 1. What's the absolute value of 1? 1. Is that less than or equal to 4? It works, right? Any number I pick in between there, including the negative 2/3 of the 2, will work. Let's pick 3. What's 3 times 3? 9 minus 2, 7. Is that less than or equal to 4? No. That's why there's no arrow going over top of this. I chose negative 2. 3 times negative 2 is negative 6. Minus 2 is negative 8. The absolute value is positive 8. That's not less than or equal to 4 either, right? We just drew a picture of all the numbers that would work for that absolute value inequality. Okay? Connor, what are my 2 problems?
Negative 2x is less than or equal to 6. Or no.
What happened to the 8?
Add it to the 6.
Well, eventually, but let's just write the,
Eight
two-
minus 2x.
all right, 8 minus 2x. And or?
And 4.
Yeah, which one?
Oh, 4.
Yeah, grade 4, right? What's the other one?
Is it just 2x or negative 2x?
Well, don't, you keep.
Oh, yeah, I know. 8 minus 2x
Okay, that stayed the same, then what?
plus 6 or 8.
Well, what do I do? Is it still greater or equal to 6, or what happened?
No.
What happened to the first one? Oops, I went to the wrong one. Above it.
Switches.
It switches, right?
Yeah.
Okay, so let's switch them. What's it switch to?
Plus or equal to
And then what?
6.
The 6 also switches to negative. All right? So change inequality in the negative 6. Okay? I knew I had to wake you up.
Yeah. Apparently.
Okay? And then from there, you guys know what to do, right? Any questions? Pretty easy day. Okay, so I'm gonna let you have the rest of the period to do these problems. You should be able to get done and submit before you leave. Yes, sir.